Hello, and welcome to the Lab Windows CVI, Ivy-specific and class driver demonstrations. My name is Sean Shaw from National Instruments. Ivy drivers make it easy to programmatically command instruments from numerous vendors. This demonstration will illustrate just how easy it is to use Ivy class and Ivy-specific drivers in the Lab Windows CVI environment. Today we're working with the Agilent Technologies HP34401A instrument driver. Now, in order to follow along with this demonstration, please download this driver and any additional required software. This software is listed at the bottom of each driver download page under the additional required software section. For assistance finding and installing the software, you can also refer to the Ivy Getting Started PDFs on the resources page of the Ivy Foundation website. To begin, let's take a look at an Ivy-specific demo that acquires a simple simulated reading. Because we're using a specific driver, this code is able to command any Agilent digital multimeter within the 34401A family. It starts by using a check error wrapper around each command. This macro will store any error in the error variable and jump to the error label at the end of our code, display that error, and then end our code safely. There is a line in our source code to demonstrate this macro in action and trigger an error, but it's currently commented out. So let's focus on the working example. Each line of our source code is commented to help explain the instructions and guide our learning efforts. The first function opens a session and initializes our simulated instrument. The first parameter is the resource ID. If another Agilent DMM in the same family was connected to your computer, you could update this resource ID and the code would run using your second DMM. Resource IDs are available within Measurement and Automation Explorer, or MAX. You may have also noticed that we sent a text string which sets simulate equal to 1. This allows us to enable simulated results. Other Ivy driver features, such as state caching, are also enabled by modifying this text string. You can see here that we have configured our instrument to use auto range and then get a voltage reading from the instrument. Next, we'll set the same range to a value of 10 and then get another reading before outputting both voltages to the screen. Now let's run our code and see what our results are. You'll notice that our first reading is much larger than the second, and our second reading is within a range of plus or minus 10 volts, just as we expected. Now let's test our error handling. What would happen if we were to set the range attribute not to 10, but to a very large number that we know the instrument couldn't handle? Now let's test our code and see how our error handling reacts. Just as expected, the error details were displayed. Now let's look at how a class driver differs from a specific driver in Lab Windows CVI. Our class driver code is incredibly similar. We initialize, configure, read, and then display just as before. We even utilize NI's error checking macro. The difference is that specific drivers use a prefix that is particular to its instrument or family of instruments. In the previous example, the prefix was HP34401A. Here, we are using the IVDMM class prefix. The only other difference is that instead of using a resource ID as we did previously in our initialize function, we're using a logical name in its place. This logical name is used as a layer of abstraction so that it is not tied to any particular instrument and must be configured in MAX. When running the demo, we can see exactly what we expected, a single simulated reading from our class driver. Now, in this demonstration, we're dealing only with class drivers, but we could integrate calls to specific drivers. This would utilize a process we refer to as upcasting and downcasting. Now we are going to copy and paste some code to demonstrate downcasting. To downcast, we simply need a handle which is returned from the getSpecificDriver chandle function. With this handle, we can call any of the specific driver functions necessary for our application. In this demo, we will modify the arrange attribute for our specific driver, take another reading, and display this second reading. As expected, we now have displayed two readings, and the second reading is within a range of plus or minus 10 volts. This concludes the Lab Windows CVI, Ivi specific, and class driver demonstrations. I hope you've been able to see how easy it is to bring Ivi drivers into the Lab Windows CVI environment. For additional information, including videos, tutorials, and more documentation, you can go to the Ivi Foundation website at www.ivifoundation.org. Thank you.